What if a logic analyzer could have networking capabilities, could be controlled remotely via a web-based interface, could decode digital protocols on itself, could support decoding over 70 digital protocols, could be a full-fledged single-board computer with expandable I/Os. Introducing the BeagleLogic Standalone, a logic analyzer that checks all the above checkboxes and addresses the challenge of making connected instrumentation accessible and affordable to all. 3 years ago, I created BeagleLogic that turns the BeagleBone Black and its variants into a logic analyzer. However, the process is quite involved and has its limitations. For example, the output streaming speed is limited by the 100 Mbps Ethernet link, and there are only 14 possible inputs out of the maximum 16. BeagleLogic Standalone addresses these issues by being a specialized hardware based on the Octavo Systems OSD 3358SM SIP, also known as BeagleBone on a chip. It offers 16 logic channels versus 14 on the BeagleBone Black. It offers gigabit Ethernet versus 100 Mbps Ethernet on the BeagleBone Black. It has an onboard RTC, 4 GB of eMMC, SPI flash, and a 24-pin expansion header with GPIOs to attach, for example, an LCD or a high-speed ADC. This compares BeagleLogic with some of the other logic analyzers available in the market, which you can see are combinations of an FPGA plus MCU, so they require an external computer to interface with. However, because the BeagleLogic Standalone is a single board computer in itself, it can offer features that other logic analyzers cannot. For example, it has networking features that enable remote debugging. It can decode digital protocols on itself using the sigrok set of tools, and it also has signal injection capabilities, which means it can affect external logic circuits as well. So this is the top view of the BeagleLogic prototype board as manufactured by GHI Electronics in Michigan. So you can see the Octavo Systems OSD 3358SM SIP on the top, while on the bottom you can see the eMMC, the logic buffer, the SPI flash, the gigabit Ethernet PHY, the microSD card slot, and the USB port. Let's move on to the demo now. So for the demo, you can see that this is the BeagleLogic prototype running. LEDs are blinking. I have connected the expansion port SPI to the inputs here on BeagleLogic. Alright, now let's open PulseView, which is the official client for sigrok. So here I select connect to device, then select BeagleLogic here, enter the TCP IP address of the BeagleLogic board, .7.2, port is 5555, and select samples for devices. BeagleLogic is found, click OK, and now you have all the 16 channels visible. Now when I click run, it will sample and display those samples. So you can see that this is SPI waveform. This here is the clock. This is the data. And this here is the CS pin, which is the first capture. Now let's move on to the web interface of BeagleLogic, which can be accessed via port 4000. Here I select the channels I want to capture, 0, 1, 2, 3, then click on begin capture. So the samples appear over here. There is no zoom functionality I implement currently, but it will be implemented very shortly as I plan on improving the web interface as the next step for BeagleLogic. The third example is going to be a command line interface where I copy this command, which will capture data from BeagleLogic, and it will decode that SPI waveform for you. So this command is already typed in. Let's execute it and see what happens. So you can see it first captured and then it decoded the protocol for us. So you can see that we had data coming from 00 to FF in increasing order. So this was all for the demonstration. Now, if you want to know more about BeagleLogic, you can visit the following websites. That's all for the presentation. Thank you.